Okay, today we're going to take a look at the nth term test. So let's go ahead and begin. Students will be able to know what the nth term test is and how to use it. We kind of saw a little bit of the nth term test in an earlier video, but let me go ahead and refresh your memory on what we're doing here. So what is an infinite series? The sum of infinitely many terms, which is called an infinite series. So if we have a bunch of terms added up to infinity, that's called an infinite series. How many ways to solve these? More than 10. But basically what we're doing here is this. We're looking at a whole bunch of types of tests, and through looking at different series, infinite series, we'll hopefully know which test to use. I have to say that you always want to try to use the nth term test first. It takes a matter of seconds. We'll learn the rest of them in the next few videos. So, to refresh your memory on what converge and diverge means, basically this. If I have the limit as n approaches infinity, so let me fix that for you. This should be infinity right here, of s of n is equal to s. So if I have a series, a bunch of numbers added up to infinity, and I get just a number, meaning a finite number, then we say that it converges. If I have the limit as n approaches infinity, let me fix that for you, of that same series s of n, and I can add up the numbers, I get some big number like infinity, then we say that the series diverges. So converge means that I'm basically getting a finite number when I add them up. Diverge means I get some huge number like infinity. Remember that the notation basically looks like this. If I want to rewrite this, I would write it a sub 1 plus a sub 2 plus a sub 3. Remember that this is called an ellipsis to a sub n and further. Okay. So let's take a look at the test itself. Nth term test. The thing about this test is this. It only checks for divergency. So it doesn't check to see if it converges. So it says if I have the limit as n approaches infinity of a sub n, and I get anything besides 0, then the series diverges. So if you get 15, negative 17, if you get infinity, then it means that it diverges. If I get 0, you have to use another test. Okay, so that's the thing. It's really easy, and I like to use this first just in case. So let's go ahead and let's take a look at the first one. It says use the nth term test. Alright, no worries. Limit as n approaches infinity of 1 over n, and if I plug this in, I get 1 over infinity, which makes 0. Now this is basically it diverges. This is a very, very famous series. This is called the harmonic series. And the harmonic series is a very neat series. If I remember correctly, basically it says this. And if you sketch the harmonic series, it looks a little something like this. And you can fill in, it's crazy, you can fill in the harmonic series and that whole sum, and remember this goes on and on and on forever. The whole sum, I believe, is equal to 1. But you can never basically, paint the area of the outside. It's kind of a neat idea. Anyways, that's more than you need. But so the harmonic series always diverges unless it's alternating, and we'll talk about that in a later video. Okay, so back to the nth term test. I don't want to confuse you guys here. So limit as n approaches infinity of sine n. Okay, so sine graph oscillates. It basically goes, the high points and low points are 1 to negative 1. And so for here, you could have two solutions if it goes to infinity. It could go to positive 1 or it can go to negative 1. So we say that this one definitely diverges, and also if you wanted to use the true test, 1 and negative 1 is not 0. So it does diverge. It's because it oscillates. We're not going to know what it actually hits. So that this one does diverge. So let's take a look at example 2. Alright, it's getting a little bit more interesting here. Now if I set the limit using the nth term test as n approaches infinity of n squared plus 1 over n cubed minus 3. Okay, remember this one is the case where we're just going to look at the highest degree and the highest degree here is in the bottom. So don't worry about the rest of this junk. The test was if the degree in the bottom is bigger than the top, it basically goes to 0. So here we need another test. It doesn't diverge, it doesn't converge with this test because it's equal to 0. We need another test. So Nth term test, like I said, it's only good for divergency. Okay, we're doing great here. Let's set it up. Limit as n approaches infinity of n squared over 3n squared. Okay, once again, we're going to look at the degrees. They're both 2, so that means the leading coefficient is the answer. So this is how we solved for horizontal asymptotes in that video. So the answer would be the leading coefficient, which is 1/3. 1/3 is not equal to 0, so therefore, guess what we can say? It diverges. Good job. Alright, let's take a look at the next one. Limit as n approaches infinity of n plus 5 squared all over 6n squared plus 7. Okay, once again, we're going to look at the degrees. So the degree on this looks like it's 1, but because I would have to FOIL it out, we would end up with a degree of 2 here. Here, this degree is 2. The rest is just kind of filler for what we need. And so here I would get 1 over 6, which is not equal to 0. So I know that this series diverges. Not too bad, huh? Okay, the last one here. If I apply this, the Nth term test, I get limit as n approaches infinity of n over n plus 1. Once again, take a look at the highest degree. It's 1, so it's equal to 1. It's not equal to 0, so therefore it diverges. However, I want to say for the problems we couldn't do where we had it equal to 0, we need another test. And so I'm excited. And there's plenty of tests to learn. So let's go back up. Let's see if we hit our learning goal. Students will be able to know what the Nth term test is and how to use it. Most definitely remember that if you get confused, just look back at the actual test. It says that if it's equal to anything other than 0, then it diverges. If it's equal to 0, then we need another test. Okay, I'll see you on the next video.